So hello guys, short and circuit team. So today I want to give you a summary of a system that we just installed here. So as you can see, we have two inverters and two lithium ion batteries. This is a 5 kVA low frequency inverter, and the same applies to that one. This is a 5 kVA lithium ion battery, and the same applies to that one. So this system is running a supermarket. So this system right here is running the ground floor, while that system there is running the upper floor. And since the upper floor does not have a lot of load, it is also running the server that serves the supermarket. So I just want to give you a brief summary, or a summary of what we've done here. So as I said earlier, this is a 5 kVA low frequency solar inverter. So what we have here, these are the supplies from the solar panels, and we have 4 isolators. Our inverters has 2 MPPTs, which means they have 2 ports for 2 input ports for charging the batteries. And these are all-in-one solar inverters, which means that during the day power is used directly from the solar panels to the appliances that are here in this supermarket. And that one, you can see from this arrow here, you can see that we are both charging the battery and both using the load, or we are inverting and charging at the same time. So this system has 20 solar panels, and like I said before, each inverter has 2 MPPTs. So, and that is why you see we have 4 isolators here. Each isolator shares carries 5 solar panels. So 1, 2, 3, 4, those are 20 solar panels, and then 10 come into this inverter and 10 come to this other inverter. From there we have this system. This is a system that controls the power that goes into the supermarket, and that power comes from these automatic transfer switches or automatic changeover switches. So basically what we've done, the inverter feeds this ATS, and then Kenya Power, which comes from this AVS here, automatic volt stabilizer, comes from here and feeds this ATS, and the same happens to this side. So this inverter feeds this ATS, and Kenya Power feeds this ATS. And so then now the power comes from, or the load comes from this ATS, goes through the system and into the supermarket. And basically that's it for the system. So you can see that we've marked that the solar is priority in this case. We've not fed our inverters with KPLC or the national grid. And so basically the inverters are purely used for backup, and when the batteries are depleted, the system automatically switches to KPLC, or the national grid that we use here in Kenya. So that is basically it. So the solar panels come through here. 2 isolators serve this inverter, 2 isolators serve this inverter. Then Kenya Power comes from here, KPLC comes from here to this ATS, KPLC comes from here to this ATS. And then from there, the power now that comes from the ATS comes through this system here and goes into the supermarket. So I want to give you just a sneak peek of the load that we have here. So if we start with this inverter right here, you can see that the load is at 34%, and it is fluctuating. Obviously now it is 41%, and it is at 1.8 kilowatts. And then our solar panels right now are giving us 2.7 kilowatts of power, or 202 volts. This other one here, our AC out is at 25%, which is 1 kilowatt, which is also 5.5 amps. Our solar panels are giving us 203 volts or 2.6 kilowatts of power. So that's a summary of this system that we've done here, and now we are in the observation stage of how this system will perform. Thank you guys, and see you in the next video.